Hello, everyone. Welcome to this workshop on geochemical modeling for Orebody knowledge and exploration targeting. This workshop is organized by Linda Bloom from Analytical Solutions, myself, Juan Carlos Ordóñez from Kinross Gold. We have a big group of internationally renowned geoscientists, geochemists, covering different aspects of applied geochemistry. So we'll be covering topics of fundamentals of applied geochemistry. We'll be talking about environmental geochemistry, interpretation of four-acid geochemistry, and also different topics on soil and till geochemistry. The reason we kind of selected all these topics is because we want to cover applications of geochemistry in the different stages of the mining cycle, from exploration to development to closure. I would like to emphasize a few things on the abstract that you have available at the PDAC website. One of the things is that geochemistry is the largest and most reliable, spatially distributed data set in many mining operations and exploration projects. This was not the case maybe 20 years ago, but now we are finding that many mining operations actually investing in full top to bottom drill core geochemistry. And that's very important because now geochemistry is becoming kind of, many mineral deposits have a baseline geochemistry. And when you have your ore bodies covered with geochemistry, then you can develop a lot of different models to support to support and solve different problems through the life cycle of a mining project. We can use these baseline geochemical models, geochemical data to actually model geological attributes. At the end of the day, many of the operational attributes that are of value drivers are geological attributes. And one of the reasons we didn't call this workshop geochemistry of mineral deposit is because every ore body is a mineral deposit, but not every mineral deposit is an ore body. So we need the concept of ore body actually means that we can mine it at a profit. So ultimately, the goal here is to use these geochemical data sets to identify the geological values, the geological attributes that are drivers of value. If you're having, for example, recovery problems due to clay, how to localize those clays. If you're having throughput issues, if you're having deleterious metals or areas with problems with acid rock generation, all of these are geological attributes that can be modeled in geochemistry. Also, once you have this kind of geochemical baseline, it's very important to continue in the process of pairing any geochemical programs with the expensive test work that commonly is done in mining operations. For instance, it is very important to pair your metallurgical tests, your environmental tests with your geochemical baselines, because anytime along the road, if you're having an issue, having a problem, then the fact that you have this test work paired with your geochemical data means that you kind of have a training data set that you can use to build any predictive model or machine learning model and solve different problems. We are having in the possibly last 10 years or 7 years an incursion of machine learning applications in geosciences, and then there is a lot of expectation on using these kind of machine learning applications to solve problems in geoscience using geochemical data. Still, I want to encourage, and in this workshop we are going to be encouraging that is really the role of fundamental geoscience, the role of fundamental applied geochemistry that should be leading this kind of algorithmic modeling. So if we have solid foundations in applied geochemistry, then we can use this kind of statistical learning methodologies to solve issues. But all of these should be guided by good geoscience knowledge. Ultimately, this baseline geochemical data, whether it's from exploration or your Orebody, is the best tool that you have at your hands to use in economic evaluation of your operations. So we'll be presenting several examples in this workshop. And at the end of the day, once you collect these data sets, you can use these data sets through the entire cycle of the mining business to solve issues. It's not just exploration, but any problem along the road, any challenge that a mining operation have, it can be solved using or tapping the value that is hidden in these geochemical data sets. I think in my view, there is long gone the time when geochemistry was kind of the monopoly of Earth's historians or maybe some greenfield geology. In today's world, where analytical costs are lower and the quality is exceptional for geochemical data, geochemistry has become really a multi-client tool. So when I say multi-client tool, is that these geochemical data sets can be used to solve problems, for example, understand problems in metallurgy, to map them, to understand and solve problems in mining engineering, environmental problems, also to find new deposits to exploration, and obviously to model geological attributes for resource estimation. So geochemistry is now basically fully fledged a multi-client tool, and it is very important to grow this knowledge of geochemical literacy so that whoever is managing the geochemical analysis, the geochemical collection in a company actually can do the best choice of keeping these data sets as multi-client as possible so that they can serve to solve a lot of problems. Some key takeaways, of course, some of the fundamentals, geochemical determinations, machine learning applications. You will see a lot of Orebody domains, either for environmental or resource domain, alteration domains, all of them thought on value. And finally, obviously, mineral deposit exploration models. All of these will be discussed in this workshop from a multi-client perspective. I hope you enjoy this workshop, and we will see you in the live discussion. Thank you.